Hi, I'm Nathan Vincent.
And I'm Grafton Conger, and today we'll be talking about Pascal's principle, how to build a hydraulic pump, and how the hydraulic pump works. So let's go ahead and head over to talk about how all the principle and the background of it is. Hey guys, as I mentioned earlier, we'll be talking about Pascal and Pascal's principle. Blaise Pascal was born on June 19th, 1623, and was a French mathematician. He also created Pascal's principle that we now know today. By looking at Pascal's equation, F1, force 1, over A1, area 1, equal to F2, force 2, over A2, area 2, we can get how much force is required to lift a significantly larger amount of force, which is actually a really interesting concept that we'll go into further later. Now that we've gone over the principle of Pascal, we will start going into how to build our prototype. Alright, so now that we've talked about the Pascal's principle and how it works and how our hydraulic pump will work, let's go ahead and get to the part where we get to design and build our hydraulic pump. So first, we're going to start off with a 0.75 inch diameter syringe, and we went ahead and attached a piece of air tubing to the end of this syringe, which we'll go ahead and attach that syringe in a little bit.
This is a 2-inch syringe. Another bit of our supplies that we have here is a piece of wood. We have a 2-inch hole drilled out so we can go inside a syringe inside of, as well as a 0.75 inch hole that we can slide the smaller syringe inside of. Now to set up our hydraulic pump here, we need to do some configuring here. First of all, first thing I do is I take some vegetable oil, pour a little vegetable oil onto the plunger here. That will reduce the friction within the system. The next step we're going to have to do is add water to our syringe here, which take me a second here. We'll add some water, fill it about halfway up, and plunger in. Now it's important that we get rid of all of the air within our syringe so it reduces the sponginess. This air is compressible, but water is not. So once we've gotten rid of all of the air within the system, we can then put our plunger through the hole, and we'll attach this tubing here. Once we've attached the tubing, go ahead and take this out. We're going to bleed the line, take all the air out of the tubing. Once we have water coming out the top here, we'll put this plunger back in. So now we have 0 air within our system. Next step will be to take our zip ties and zip tie our tubing to the syringes. This is a fail-safe in case the pressure gets too high and wants to blow the syringes off the bottom, which you'll see later on in the video as we put on a lot of weight. And that's how we build our hydraulic pump.
So now that we have it built, we'll get right back with you. We're going to go get set up to do a few tests.
Now I'm going to explain the math behind our demonstration to show how we can use a small force to lift a large force. So, using Pascal's principle, we know that force divided by area is equal to pressure. And a pressure within a system is the same throughout the entire system. So, we know that, for example, force 1, which would be our small force, divided by our area, will be equal to the large force divided by the large area. So, first things first, we need to figure out what the area of our small syringe is. We take our area formula here, pi over 4 times the diameter, 0.75 squared, which gives us a 0.44 area for the small syringe. And then for our large syringe, we have a 3.14 area. We take those numbers and we plug them into our rearranged formula here. F1 is equal to F2 times A1 all over A2. This will give us a way to calculate how much force we need to apply on the small plunger to lift a large force on the big plunger. So for example, let's say we want to lift 15 pounds on the large plunger. We'll only need 2.11 pounds of force on the small plunger. So let's get right into it. I'm going to put 10 pounds onto our large plunger here. And I'm going to take 3 pounds here. I'm going to lift up that 10-pound weight over there with only 3 pounds. Oops. That happens sometimes, folks. Okay, so we'll have our weights here. And there is friction within the system, so that's why we have to use a little more than 2.1 pounds. So that's why we have 3 pounds here. So as you saw, it was able to lift the 10 pounds over there. Now we're going to demonstrate that it can lift 25 pounds with only 5 pounds. So if you'll help me out here, Grafton.
All right.
Let's see. 5-pound plate.
We're going to go ahead and put the 5-pound plate on there so that it doesn't skyrocket out of the system.
Okay, let me lift the plunger up here. Okay. All right, now I'm going to put on the 25-pound plate. Try to get it balanced. Okay, let go.
All right. So as we mentioned earlier, we do have a little bit of friction in the system, and we also had to add the blocks so that the weight would stay on. So we have to add an additional 2.5 pounds for it to lift the whole system.
All right, and now that we've demonstrated with some smaller weights, we're going to see what we can actually lift. We're going to test our limits here.
Alright guys, so as we said, we're going to try to have a little bit of fun with it. So we're going to try to see if we can lift me. I weigh around 160 pounds, and we calculated it to be about 22 pounds to be able to lift me. So Nathan's going to see if he can lift me using that 35-pound weight. So it should work pretty well since it's got a little bit more weight than needed. So let's go ahead and see if we can try it. You ready?
Yep.
Alright.
All right, going to let go. You can't tell because it's a very, very small distance that we're lifting here, but the 35 pounds is enough to lift them up. You can see 35 pounds drops. I'm not really pushing down on it.
I can feel it going up. So.
There you go. And yeah.
Alright, so we lift 160. You want to see if we can do a little more?
Sure.
Alright, so we'll be right back. We're going to get set up again. Alright, so we're back. So we have another special guest on the show today, Nathan's dad. He weighs about 200 pounds. So we calculated it, and it's still under 35 pounds. It only actually takes 28 pounds of force to be able to lift 200 pounds. So we're still going to use the 35-pound weight. So whenever y'all are ready.
All right, I'm ready. All right, I'll look. All right, so we're going to let go of the weight here. And it's lifting him up. See the weight once it touches the bottom?
As you can see, he's just using his fingertips, so you can see he's not lifting himself.
So you see him lifting him up and down a couple times with just the 35-pound plate here. And yeah.
Alright, so we're going to do round 2, 225 pounds now with the added weight.
All right, I'm going to lift up the weight here, and I'm going to let it go. Oh, blew out the bottom. All right, well, it looks like our system won't take over 100 PSI in the system.
All right, guys, thanks for watching. And it looked like our system kind of maxed out at 200 pounds. So we'll see you next time.